the last video, I was talking about the integral of a trig function. So let's take a cos square of x. So it is a trig function of cos of x. So that's my function g of x is my cos of x, where my function f is a square. And this was multiplied by sine of x. Okay, so since it's the same angle and my function sine x is an inner derivative of g, so it's a derivative of cos of x, I could solve this integral given with respect to x. I could solve it by inspection. In this example, the guess of cos cube of x will work very well, because if I check it, what's the derivative of cos cube of x, then this derivative would be 3 cos square of x times the inner derivative, which is sine of x, which means that in my guessed answer, I just need a coefficient of 1/3 at c, and my integral is solved. So what will happen if instead of cos square of x, I will take a simpler one, cos, but of 2x, and I will multiply this by sine of x with respect to x. Okay, isn't that simpler? I don't have a power of 2, I have just the cos of 2x. Is it simpler? Well, the answer is no, because sine of x cannot be the inner derivative of the function cos of 2x. Okay, so what I can do in here, if I try to take a guess, and let's say I will guess cos square of 2x to be my answer, what is the derivative with respect to x of cos square of 2x? Okay, so it will be 2 times cos of 2x times the inner derivative of cos of 2x, which is sine of 2x, and then it still will be times 2. And that's the problem. Here you've got sine of 2x, where here it's only sine of x. So this is not an inner derivative. Problems like this is our last problems with purely trig integration. When we are looking at a multiplication of function sine and the function cos under the integral, but that multiplication is of different angles. So it can be 2x and 3x. It can be 5x and 7x. It can also be a combination of cos of A and cos of B. That is even more obvious that this function cannot be the inner derivative of a second function. For this, we've got a particular table that we need to use. So please open your textbook on page 129. You will see the table there, and we need to talk about this table a little bit. Okay, please pull your textbook out, page 129. So this table is called a product sum table because it refers to a product of your compound angle formulae that results in a product of trig functions of different angles. Now that trig functions can be a sine and a cos, but it can be cos and a cos or sine and a sine. Depends on what we need. This table will always be given to you in the test or in exam, the same as the table of derivatives or table of antiderivatives will also be given. So there is no point in learning those formally. With your differentiation and anti-differentiation, it's probably good to know at least the basic and learn by heart, but this is not a basic. Please don't try to learn this by heart. I'm going to then apply this product sum formula to the two examples that you have on the page 129. And the first example is to find an antiderivative of a function defined as sine 3 theta, but this function of sine 3 theta is multiplied by cos of theta. Obviously, if I write it as an integral, I must not forget to write this as d theta with respect to theta. Right, a textbook example, that's how it is tested in exams. You have a combination of a trig function sine, trig function cos of different angles. Remember, product sum table refers only to the product of a function sine and the cos and does not refer to any other combination of trig functions. So if you have any other combination of trig functions, then they must either be found in your table of derivatives, or if not on the table, it will be solved by using a u substitution or by inspection. So what will I do in this example? Well, in this example, I have to look at my product sum table to replace the product with either a sum or subtraction. So if I have sine and the cos, then this is my first option. So this will be my little a and this will be my little b. So this integral is equal to half times the integral of sine of 3 theta and theta plus half the integral, I'm splitting the integral, sine of 3 theta minus theta. Both integrals will be with respect to theta. Right, so now I've got half integral. You don't have to split it if you don't want to, so you can write it as sine of 4 theta plus sine of 2 theta d theta. Okay, just remember about that half that you will have to multiply in. What's the integral of sine of 4 theta? Well, firstly, it will be minus cos of 4 theta using the table of integrals. However, there is a 4 here, which means that I will have a coefficient of minus 1 over 4. The second one, in a similar way, it will be minus cos of 2 theta. So I'm running out of space. So the coefficient will be 1 over 2. Okay, now multiply everything out and we get minus 1 over 8 cos of 4 theta minus 1 over 4 cos of 2 theta plus c as my answer. You can check it. It's at the bottom of page 129, but you have to do this example on your own to understand the use of product sum table. We're going to look at one more example. Okay, so the next example that you have in your textbook is the integral of cos of 2x times cos of 5x. Okay, one of those examples when I have a combination of cos with a cos of different angles. I'm not going to even try to do any other ways but to use the table with product sum formula. Right, so this is my angle A, this is my angle B. Look at the table. What does the table tell us? How can we replace it? Please be careful not to lose the integration sign. It's still the integral of the sum. So if I have cos and a cos, that's the third of the formally given, so the constant a half, and now we've got cos of the sum of the two angles, so it's 2x plus 5x, plus cos of a subtraction of two angles, 2x minus 5x. All of this will be dx. Okay, so we've got a half times integral of cos of 7x plus cos of minus 3x, all with respect to x. Right, we have to remember that we still have to follow all the rules of trigonometry. So cos of minus theta is the same as negative. So, sorry, cos of 7x, if I want to look at a fourth quadrant and I've got negative angle, cos of minus 3x is looking at negative angle. In the fourth quadrant, cos is positive, so I can change it to plus cos of 3x dx. Okay, so let's integrate now. So my integral is now equal to half times integral of cos is sine of 7x with a coefficient of 1 over 7 plus the integral of cos of 3x is sine of 3x with a coefficient of 1 over 3 plus c. Okay, you can multiply the half in. This example is solved on a page 130 in your textbooks. So what you need to do, boys, now is exercise 7.3. So that is exercise on the page 130, and I would like you to do question number 2. But I want you to first do the last 3 problems, so G, H and I on this page, because the G, H and I refer to the product sum tables, and then you have to do questions A to F that are from the previous video and involve the cos square function or sine square function. Please remember, like in question number C, when you've got pi over 2, you need to reduce that first. Okay, so in question number C, you've got 3 sine square of pi over 2. My stylus is giving me trouble again. Minus 2 theta. Why can I just swap it like this? Because it's a square, so I don't have to worry about taking a minus out. I also don't have to worry about which quadrant I am. I must just remember that pi over 2 is a 90 degrees, so this needs to change into a co-function, which is then cos square of 2 theta. So just a little hint for the example C. The answers you've got in your textbooks in the section with the memos for section A on the page 180. If you have any problems, snap the photo, send it to me or to Mrs. McDonald to get help. Good luck, boys. After this is your homework. After this, there will be quite a lengthy worksheet with the trig integration. Good luck.